Assalamu alaikum dear students. In previous video lecture we had discussed the concept of arithmetic progression, arithmetic mean, and the sum of the first n terms of this arithmetic progression or arithmetic sequence. Now today we are going to discuss the exercise 9.2. Now the question number 3 of this exercise is: in AP the first term is 2 and the sum of the first 5 terms is equals to the 1/4 of the next 5 terms. Show that the 20th term of this sequence or this AP is minus 112. Here the first term is 2. This means that A equals to 2 because A is the first term of, or we notify the first term by A of an AP. Let D be the common difference of this AP. Then the sum of the first 5 terms equals to A1 plus A2 plus A3 plus A4 plus A5 equals to A is the first term, A2 means second term is A plus D, third term is A plus 2D, while as fifth term is A plus 4D. So after adding these A and A plus D's, we get 5A plus 10D. So this is the sum of the first 5 terms. Now the sum of next 5 terms or second 5 terms is A6 plus A7 plus A8 plus A9 plus A10. We know that if A is the first term, D is the common difference, then nth term is A plus n minus 1D. So here sixth term becomes A plus 5D, while as 10th term becomes A plus 9D. So by sum or adding these terms, we get 5A plus 35D. Now by given condition or by the question, sum of first 5 terms equals to 1/4 the sum of the next 5 terms, which implies that 5A plus 10D equals to 1 upon 4 5A plus 35D. Hence, by cross multiplication, it is 20A plus 40D equals to 5A plus 35D, or 15A equals to minus 5D by simplifying above expression or above equation. But A equals to 2, which implies that substituting A equals to 2 in this equation, we get D equals to minus 6. Since we know that the nth term of this AP of any whose first term is A and common difference is D is given by A plus n minus 1 into D, which implies that A20 means here n is 20 is A plus 19D. But A equals to 2, D we calculated equals to minus 6, which implies that putting A equals to 2 and D equals to minus 6 in this A20, we get A20 equals to minus 112. Hence, the 20th term of this AP whose first term is 2 and the sum of the first 5 terms equals to 1/4 the next 5 terms is minus 112. So in this way we proved the 20th term. Now the question number 4 is: how many terms are needed in this AP? Here the given AP is minus 6 first term, second term is minus 11/2, and the third term is minus 5, so on and so forth, such that the sum of those terms is minus 25. This means that here we have to find the number of terms, that is we have to find n. The given AP is minus 6, minus 1/2, minus 5, so on, which implies that first term means A is minus 6. Now the common difference D, because this is AP, which implies that difference is same throughout. Hence difference equals to second minus first term, that is minus 11 upon 2 minus 6, that is 1/2 after simplifying this. Let n be the number of terms such that the sum of those terms, that is these n terms, is minus 25. We know that here we have A, we have D. In terms of A and D, sum of the first n terms is given by n/2, 2A plus n minus 1 into D, means sum of the first n terms, which implies this expression equals to minus 25. Substituting A equals to minus 6, D equals to 1/2, we get n square minus 25 n plus 100 equals to 0. So this is quadratic in this n, where n is an this natural number. So this means that we have to solve this very quadratic equation. So by splitting the middle term, so minus 25 can be written as minus 20 minus 5, because minus 20 plus minus 5 equals to minus 25n, and their multiplication is 100, which implies that this n square minus 25 n plus 100 equals to n square minus 20 n minus 5 n plus 100. That is this. Taking n common from first two terms, that is n into n minus 2, and 5 from next two terms, that is minus 5 into n minus 20, this equals to n minus 20 or n minus 5 equals to 0. So either n equals to 20 or n equals to 5. Hence, the number of terms we needed such that the sum of those terms is minus 25 is either 20 or 5. This means that we need either 20 terms or we need 5 terms such that the sum of those terms is minus 25. Now the question number 5th of this exercise is, in an AP, if the pth term is 1 by q, this means that here p is the natural number, and the qth term is 1 by p, we have to prove that the sum of the first pq terms is 1 by 2 pq plus 1. Let a and d be the first term and the common difference of the given AP respectively. We know that the nth term of AP is an equals to a plus n minus 1 into d, which implies that AP means pth term is a plus p minus 1 into d, while as qth term is aq equals to a plus q minus 1 into d. Hence, but by the given condition, pth term is 1 by q and qth term is 1 by p, which implies that 1 by q equals to a plus p minus 1 into d, and 1 by p equals to a plus q minus 1 into d, where a and b are here unknown, and 1 by q and 1 by p are known numbers, known natural numbers. Now subtracting these two equations, this equation and this equation, we get 1 by q minus 1 by p equals to a plus p minus 1 into d minus q minus 1 into d. So cancelling a and a, taking d common, so we simply get p minus q equals to p by q from this left hand side, and on right hand side we get p minus 1 into p minus 1 minus q minus 1 into d, this one, which implies that by simplifying this we get p minus q into d, which implies that p minus q into p by q equals to p minus q into d. Cancelling p minus q, we get d equals to 1 by pq. But we know that AP equals to a plus p minus 1 into d, which is 1 by q equals to a plus p minus 1 into d. Substituting in this, d equals to 1 by pq, which implies that a equals to 1 by pq. So in this way we find this value of d, that is common difference in terms of p and q, which is 1 by pq, and the first term of this AP is 1 by pq. Now we have to prove that the sum of the first pq terms, that is spq, but Sn equals to in terms of a and d is n by 2 2a plus n minus 1 into d, which implies that spq equals to pq upon 2 into 2a plus pq minus 1 into d. Now a is 1 by pq, d is 1 by pq, so substituting a and d as 1 by pq, which implies that this spq equals to pq upon 2 into 2 plus pq minus 1 upon pq. Here this pq and pq will cancel. 2 minus 1 is plus 1, so this means that it is pq plus 1 upon 2, or 1 by 2 equals to pq plus 1, which implies that the sum of the first pq terms we have proved to be 1 by 2 plus pq plus 1. So in this way we find the sum of the first pq terms. So inshallah in tomorrow's video lecture we shall discuss again this exercise 9.2. So thank you.